Hi, welcome to online tutorial series on Arduino and IoT. This is lesson 19, and in this lesson we will talk about how to interface a TFT LCD or colorful TFT LCD with Arduino. So with remainers till the end of this video, we will talking about a lot of basics of LCD display, and then we will also talk about like how to display a sensor data on the LCD. So further, we also provide online training, help in technical assignments. We also do freelance projects based on data science, Python, machine learning, etc. So if you have any such requirement, then you can let us know by contacting us through our website, which is www.jcbrolabs.org, or you can also mail us at info@jcbrolabs.org. Okay. So let's start with the basic. That means, as usual, first of all we'll talk about the LCD which we are going to discuss. So today we are going to discuss this 1.8 TFT LCD screen interfacing. So generally this comes under these two formats, like AMR 1.8, and then another one is this one in this format. So both of these two are TFT screen. The library which we will be using is a inbuilt Arduino library, tft.h, and it is mainly for ST7735 driver LCD. So these LCDs are based on a driver microcontroller. So basically there are two kind of driver microcontroller. One is known as the ST7735 and another one is I9163. So these two LCD which we are going to discuss are based on this particular driver. Okay, apart from it, there are several other libraries like Arduino GFX and Arduino Adafruit GFX and Adafruit ST7735. So as we discussed, we are going to connect specifically this particular LCD. Okay, by the way, both are the same. So first of all, we will talk about the pin description of it. So if we talk about pin description of this one, so first pin is VCC, then we have second pin is ground, right? Then third pin is the chip select. Okay, so or the CS pin. So in some LCD TFT, it is this pin also written as SS, or it is also can be written as TFT_CS. So there are several names which represent the same thing. Then another pin is reset. So this is RST. Okay, and then we have another pin as A0. Okay, so this A0 have different name with the different pins. So A0 can also be in some other LCDs, it can also be written as D/C. That means data register or command register select. Okay, so data or command register select, or it is also written as DC or RS. Okay, so all those names represent the same thing. Then we have a pin number SDA. Okay, so SDA is the data send or the serial data, or because these are the SPI interfaced, here it represents the SPI. So SPI means this SPI protocol will be used to transfer the data. So this SDA is corresponding to the MOSI. So in many microcontroller, MOSI is given instead of this SDA. So this SDA and MOSI both are the same. And then we have SCK. So this is for clock. So in some other controllers, so on LCDs, it can be given as like SCL, or it is also known as the serial clock. So this should be kept in mind. Our names could be either in this way or the some other pins. Like similarly, like as we can see here, in this kind of the LCD, there are two things. One for this is for SD card. So some pins are for SD card selection and some pins are for LCD selection, right? So here these particular pins are for the LCD and this particular pins are for SD card. Remember, so here LED minus and LED plus will go as corresponding ground and plus 5, and then VCC. Here we have reset, A0, SDA, SCL and CS. So these are the same name as given here. So as we discussed, we will be talking about in our code we are using this TFT .h header file from Arduino. So let's talk about the hardware connection which we have connected from the Arduino. So here we have Arduino, right? So in this Arduino we have SPI is connected from 10, 11, 12, 13, right? So we have measure 5, let's connect here name, write it name, pin number 8, pin number 9, pin number 10, pin number 11, 12 and 13. Okay, and here we have this LCD. Okay, so connections are like pin number 8 is connected to the reset of this LCD, and then pin number 9 is connected to DC, which was data or command register DC or A0, and then this pin number 10 is connected to chip select. Okay, so there was a pin chip select as we discussed, and then pin number 11 is connected to because it is a MOSI pin, so it is connected to the SDA pin on this LCD, and then pin number 13 is connected to the SCLK. Okay, SCL or SCLK. So this is a hardware connection which we have created. Okay, so then we will go for the programming. So prior to it, let's have a look on the hardware circuit which we have created. Okay, hi, so this is our hardware. Here is the LCD and it is connected to this Arduino Uno board as per the connection diagram which has been provided in the documentation. And from here this VCC and ground are being connected here, to power rails have been provided. Further we also have connected a potentiometer so that we can display this voltage data on this LCD. So let's move forward with the programming. So you have seen our hardware circuit. Now let's have a look. Okay, prior to burn the program on hardware, we have created a model on Proteus as well. Okay, so let's have a look on the model on Proteus. So yeah, here we have created a model on Proteus. So this TFT LCD is you can find by the name of simple by TFT. So you will get here ST7735 TFT. So it has lot of pins. So pin connections are here like this. You can visualize them for proper understanding, right? So as this D1 to all these pins up to RD are connected to +5, right? Because we are not reading anything. And then this DC pin is connected to pin number 9 as we talked about it, right? And similarly we have this SCL which is connected to pin number 13, right? And then we have chip select pin. So this chip select pin is connected to pin number 10. Yep. And then we have RES pin which is connected to pin number 8 as we talked about it. And here this is the SDA line. It is connected to D0 of this LCD. Okay, and rest of the pins are connected to plus VCC. And we talk about other pins of it. So here our connections are like this. This TF select, GS and all these pins are connected to ground. These 4 pins, 1, 2, 3, 4, 5, these 4 pins along with this GS, TES, FL and this IM2 and P63, these are connected to ground, and IM1, IM0, SPI 4 wire, and this LCM, these pin are connected to +5. So this is how we have connected this LCD inverters and their connection diagram with the Arduino. So these are similar to the diagram connections which we have created, right? And again we also have connected a potentiometer. So instead of a real sensor, we will be displaying the read voltage from this potentiometer to the LCD. Okay, so we have connected this potentiometer as well. Okay, so now let's it was all about hardware connections. So let's move towards the programming part. Okay, first of all we'll create a new file, and first thing we'll do, we will save it. So let's save on desktop and by the name of lesson 18 underscore TFT. Okay, so first of all we'll add header files. First header file is hash include tft.h, and then hash include spi.h. Now we will create 3 points or 3 constants. So hash define that is RST as pin number 8, hash define then DC as pin number 9, and hash define CS as pin number 10. Okay, so now the next task is to create a TFT object that will be created by like this TFT, and then the name of the object equals to TFT. It needs 3 parameters to pass. So first parameter is CS, second is DC, and then third one is the RST. So these parameter has to be in the same sequence. So this is how we created these parameter, this TFT object. Now first of all we'll create LCD.begin. So it initialize this LCD, and then we will set its background. So its background will be LCD.background, and it has to be red, green, blue color. Okay, so it takes red, green, blue, but first object in this API or in this library is blue, green, red. So okay, so first of all we create a red color. So for red we have to create like this, or we have to type like this, right? And then we have to set size LCD.set text size, and let's say 2. Okay, so there's something we should discuss about this text size. So basically if we talk about this LCD, right? Okay, so let's increase it. So LCD is a combination of rows and columns, any display object, and these are the rows, and these are the columns, and these are the rows. So each point like this, it represents a pixel. So it starts from like 0, 1, 2, 3, 4 and so on, and similarly these rows start 0, 1, 2, 3, 4 and so it is. So if we have our LCD as 128 cross 160, right? So this is X and X size, and this is Y direction. So 128 cross 60, that means it has 128 rows. So it will go up to 127, and it will have 159 columns, right? So this is how LCD each pixels is represented. So, okay, so when we are talking about 0, 0, so it represents this pixel. 0, 1, then it will represent this pixel. So by default in this library, each character is being displayed by 5 cross 7 characters. Okay, so here it was rows and columns, here it is opposite, here it is column and it is the rows. Okay, so it will take 5 column and 7 rows. So the size corresponding to it is represented by 1. So if say a size of 2, right, if we pass size of 2, it will correspondingly multiply by 2. So there will be 10 columns and 14 rows and so on. So if we say size is 3, so there will be 15 columns and 21 rows. So this thing has to be kept in mind if we want to display the character exactly or at a specific location. Okay, so this is the size which any character will take while getting displayed on this LCD through this particular library. Okay, now so we can also say like this, there are 5 columns and 7 rows. Okay, so this was it. And one more thing, if we talk about display a string, so string automatically, let's say if we want to display a complete string into it, let's say JCBRO. Okay, so depending on the size, it will take a gap of the corresponding pixels in between these two characters, right? So if the size is 2, it will take 2 pixels in between the adjacent characters. If we take a size of 3, it will take a 3 pixels in between adjacent character. So based on this particular information, we can easily find like how many character we can display in single row, and how many in a single row, and how many rows we can put on entire screen. Okay, so that is very important. So right now we are setting the size of 2, so that means it is taking 10, 14 pixels to display a single character. Now let's we have to write LCD.stroke. So this is specify like by which color we want to display the text on the screen. So again we have here it was red color, so we will display a text in green color, right? And then LCD.text, so let's say JCBRO India. So there are how many? 1 2 3 4 5 6 7 8 9 10 11 12. Okay, so 12 and multiply by 7. So I hope it will display it, and we are displaying, it is the location X and Y location from where we want to start display. So we will displaying from 0, 0 location. So let's compile it. Okay, export compile the library, right? And let's see on the this simulation. So first of all we put the path. Okay, open. Okay, and let's run it. Okay, so exactly as we predicted, so red background and then green color. Okay, so let's write something else. In the next line, let's say we want to display some other thing. LCD.text think India. So its X location should be 0, and the Y, as we discussed, size is 2, so 14 pixels are being used for the Y location. So we'll starting from 15, and in the next line we'll type LCD. We'll take a different color for it. So let's LCD.stroke 0, 0, okay. If we take a red color, it will not be displayed, so we'll take a blue color. And for the third part, we'll take a very different color. Let's say 100, 200, 100. I am not sure what kind of color will it be. So LCD.text think innovation. So I think it will not display completely. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Okay, so let's change the text size. LCD.set text size of 1. Okay, now it will display it. So it will take another 7, so between 22. So we'll display it 0, 24. Okay, so let's see if we are able to display it completely. Okay, so let's run it again. Okay, so we got some problem with this. Okay, so there were total 14. It is fine, but it is not expected. 14 plus 14, it was 29. Okay, so okay, let's make it to something 20. So that let's, and again 34. Then let's start with 40. Okay, now I hope it is compiled. Yeah, JCBR India, think innovation. Okay, so this is how we can display a text. Now let's move forward with the displaying, or as we discussed, we will display the sensor value as well. So instead of the sensor, we have connected a potentiometer to the A0. So the potentiometer connection are simple. Okay, one point is connected to VCC, another point is ground, and the variable point is connected to A0. Okay, so let's write a program for that. Also, displaying a sensor value is a little typical. So what will define first, because this LCD.text can display only the string. Okay, so first of all we'll define voltage type of array with 4 element into it. Okay, so we want to display that particular data again and again. Okay, so we'll read the analog voltage and convert it into a string type. So a string type, we are taking the analog voltage, so equals to a string, and then analog read a capital A 0, comma 5.0 divided by 1024.0. okay, so it will read the analog voltage and then convert it between 0 to 5 range, right, and then it will convert into a string type. Now we need to convert this string to character array. Okay, so for that we type like voltage dot to char array. So in this we will take this voltage variable which we have created, so voltage comma 4. So what will this do? This will convert this string value into an voltage character array, and that character array will be stored into this voltage variable which we created here. Okay, so now we'll simply display it like simple. So LCD dot stroke, so let's change the color and let's make it 100, 0, 100, right, and then we'll LCD dot set text size, take it to, and then we'll display first LCD dot text voltage, comma, and so LCD dot text, voltage, comma. First of all, we'll display a voltage there somewhere, so that a voltage should be written and then voltage value should be displayed correspondingly. So we'll make LCD dot set text size of 2 and then LCD dot text voltage, and it will be from, let's say, 0, total 10 character will be there, 0, 60, right, and then this will be from 0, total 5 and then 6, 1, 2, 3, 4, 5, 6, 7, 8, right, so 8 into 10, 80, near about x location will be 80, so we'll take, being on safe side, we'll take 100, x 100 comma y location will be 60. Now we want to update it. So in order to update, first of all we need to clear the previous screen. So we'll make a delay of 250 millisecond, and then in order to just clear the text, we will display the text again with the same color as that of the background. So it should be, remember, if you want to clear any display, so make the text color as that of the background, because in this library there is no specific command to clear the display. Okay, so we will make again like I'll say so first of all we need to change the stroke to that of the background. So background is 0,0,255, so 0,0,255, and then LCD dot text, again voltage at the same location 100,60, and then it will be keep on repeating at an interval of 250 milliseconds. So let's first check whether it is working fine or not. So it is compiling, sir, done compilation, and let's see. Okay, so here it is, voltage 1.4. so if we change it, okay, yeah, 2.8, 3.4.2. Alright, so our voltage is being changed in real time, so that's cool. Okay, let's make this change color as well, voltage. Okay, so make it something different. So we can make it LCD dot stroke, let's make it simple blue color. Okay, so we'll make it 255,0,0. Okay. Sketch export compiled binary. Yeah, here voltage 1.1. Okay, so it is working fine on the simulation. Now let's download it on the hardware and let's see how it looks like. Let's upload it. Okay, so here's our real hardware, and it is being displayed perfectly fine on it. So voltage is being displayed as 4.4. So let's try to change the potentiometer value so that we can increase the voltage. So yeah, so this value is changing and it is being displayed in real time. Okay, so I hope that's it for this TFT interfacing with the Arduino. Okay, so you have seen the data on the real hardware and it is working perfectly fine. So I hope you learned a lot from this video, and if you have any suggestion or any doubt, you can let us know by commenting below this video, or you can also reach us at info@jcbrolabs.org. So finally, we also provide online training, help in technical assignments. We also do freelance projects based on data science, Python, machine learning, etc. So if you have any such requirement, then you can let us know by commenting below or by contacting us through our website, which is www.jcbrolabs.org, or you can also mail us at info@jcbrolabs.org. So that's it for this video. Thank you.